All right, the back is reminding us about some of the review in radical form and exponential form. So let's check this out. It wants you just to rewrite this one. So if there's a 7 on top and a 4 on the bottom, that means that 7 is your exponent and the 4 is your index. So we would write this as the 4th root of x to the 7th. But it not only says, 4th root of x to the 7th. It not only says to rewrite it, but then it says to simplify it. So we're going to look at this in TIA's mode. 1, 2, 3, 4, 5, 6, 7. There's 7 of those x's under the radical, and we're looking for groups of 4. So since I have a group of 4, I can take one out. No more groups of 4, so the rest are left underneath. And that's it. There's my answer. I used radical form first, and then I used TIA's method of simplifying the radical. How'd you do? All right, next one says to go ahead and first put it into radical form, and then we're going to use TIA's method. So 5th root of a to the 16th, b to the 9th. And here we go, stretching it out in all its glory. There's 16 A's and 9 B's. What are we looking for groups of? You got it. Group of 5, group of 5, group of 5. So if we've got 3 groups of 5, every time I circle one of those groups, an A can come out, another A can come out, another A can come out. That's going to become A to the 3rd. And then group of 5 leaves me 4 left over. So AB comes out. What's left over inside? This A had no group, and these 4 B's had no group. So it becomes AB to the 4th. So my final answer is A to the 3rd B, 5th root of AB to the 4th. Okay, next one wants us to rewrite it the other way into exponential form. For example, y to the 24 over 6, and then to simplify. This is Tehani's method. What is 24 over 6? It's just 4, and so we're done. This next one is going to be rewritten as x to the 21 sevenths, y to the 19 sevenths. And let's look. Do those work out to whole numbers? 21 sevenths, yes. 7 goes into 19 2 times. So this is going to become y squared, but there's 5 left over. So that's going to leave us y to the 5th inside left over. All right, next is simplifying with the exponent rules. Remember that I highly recommend writing this out when it's a base of 3. An exponent of 3. Write it out 3 times. And then this one's happening twice. This is called expanded form. So see this right here? There's 3 of these. And there's 2 of these. Okay. Let's multiply them all out. -2 times -2 would be +4 times -2. That's -8. And then do the add rule. X squared, x squared, x squared, 246 would be x to the 6th. There's the little shower your power shortcut. And then back here, I've got 3 times 3 makes 9, and x times x makes x squared. Final step would be -72 x to the 8th. How'd you do? All right, next one. Let's look at the subtract rule when we're dividing. But this number that's in front, you guys, this is just a straight up fraction. So think of it separate. Like, how would I reduce 20 over 16? Both these can be divided by 4. So 20 divided by 4 would be a 5 on top. 16 divided, this is going to reduce down to just 5/4. Okay. Then we've got x to the negative 3 minus 5. And then we've got y to the first power minus a negative 2, which essentially is going to turn into plus 2. So 5x to the negative 8, y to the third, because 1 plus 2 makes 3. So my final step, this negative exponent needs to move downstairs, and the y to the third stays on top. How'd you do? Simplify each expression without a calculator. 625 can be rewritten, look at your green sheet, as 5 to the fourth times 3/4 power. That makes 12/4, or just 5 to the third, which is a final simplified answer of 125. 81 can be rewritten as 3 to the fourth power. 4 times 3 is 12. 12 halves is 6. 3 to the sixth power, which is 3 times 3 times 3 times 3 times 3, gives us 729, fully simplified. All right, last but not least, graph this function, getting all these parts. So my stretch, you got it, is 1/3. My vertex is right here and right here. So that is -2, -1. My line of symmetry goes straight through that x of the vertex. The domain of every parabola goes from -infinity to infinity. And let's go graph it before we talk about the range, the min to the max. Let's see what it looks like first. So putting a dot here, this is going to be an upwards orientation parabola, and it's going to have a stretch of 1/3. So out 1, up, boop, 1/3. Out 2 is up, boop, 4/3. Out 3 would be up 3. Now, some of us are still unclear on where I'm getting that. Normally, we go out 1, up 1 times 1 is 1 squared. Out 2, 2 squared is 4. Out 3, 3 squared is 9. But we don't want to go up the normal parent stretch. We want to go up 1/3 of the normal parent stretch. So what is 1/3 of 1? It's just up 1/3. What's 1/3 of 4? It's up 4/3. What's 1/3 of 9? It's going to be up 3. So that's where we get that out 3, up 3 as an anchor point for the 1/3 stretch. And then you're just going to go ahead and connect it as best you can, hopefully prettier than mine. And then you're going to draw in the line of symmetry straight down the middle of that vertex and label that line of symmetry at x equals -2. Now let's talk about the range. The lowest point on this graph, do you see that it's going to go here through -1? And the highest point on this graph goes to infinity forever. And so -1 is closed bracket inclusive, and infinity goes on forever. So were you thinking that from -1 to infinity? Awesome. That's it. Did you remember how to graph? Good job.